Please open to page 292 in your student journals. In section 9.4, we're going to continue solving our quadratic equations, and in this section we're going to learn a method called completing the square. What I want to do is just go through exploration number 2, just to show you why the method we're using is called completing the square, and why we have to use this method instead of just getting to use square roots like we did last section. Letter A asks us to write the equation modeled by the algebra tiles. Now don't worry if you've never worked with or seen algebra tiles before. This is just to help us make the idea of completing the square more visual. The larger tiles are an x squared. The longer tiles represent x's. So on the left-hand side of the equation, we have x squared plus 6x equals, and we have 5 negative 1s over on the right side. So as you look at this equation that's represented by the algebra tiles, it looks different than section 9.3. In section 9.3, if we had an x in our equation, there was only one x and it was being squared. Now in section 9.4, we have standard form, so we have an x squared, but we also have an x to the first power. So we cannot solve these just by using square roots like we did in 9.3. I can't find the square root of just an x to the first power. So let's take a look at letter B. It says use algebra tiles to complete the square. So I want to make the left-hand side into a square. In order to do that, I have to put in 9 little tiles and they all need to be positives. If I put 9 tiles on the left side, that means I also have to put 9 positive tiles over on the right side also. Whatever I do to one side of the equation, I have to also do to the other. And again, don't worry about if you've never worked with algebra tiles before. I'm just helping us visualize that we are making a square through this process. The next thing we want to do is we want to actually write the two expressions that are being multiplied together to get this square. I know some of you like to factor this way, where we actually drew boxes. And in order to come up with this big tile is x squared. So in order to get x squared, we had to do x times x. Up in the upper left corner, we are multiplying. And then this section right here is 3x, so we have to do x times 3, a positive 3. And then in order to get positive 9 down here, we need another plus 3. So what we are multiplying together is x plus 3 times x plus 3, and that will equal, we have negative 5 plus 9 on the right side, which will give us 4. So in order to make a square, we had to add 9 tiles to each side. Then the expressions that we're multiplying together to get that actual square are x plus 3 and x plus 3. Since it's a square, those dimensions should be the same. They should be the same there. So we can go ahead and write this. If it's x plus 3 times itself, we can write this as x plus 3 quantity squared equals 4. Now by making that a square, by completing the square, now I have an equation that looks familiar from section 9.3. Now from here, I I only have one x in my equation, and that x is being squared. So now I can take the square root of both sides to solve. This one's a really nice refresher for us from 9.3. Solving this type of equation with square roots, I know, was one little area of struggle for us in 9.3. Taking the square root of the left side just undoes the squaring, so we're left with x plus 3. And then when I take the square root of 4, that could be positive or negative 2. So now in order to solve, here's where some of us got stuck. We weren't sure what the plus minus. That means x plus 3 could equal positive 2, or x plus 3 could equal negative 2. Notice they're both x plus 3. I do not change the addition sign. Subtract 3 from both sides. We get x equals negative 1. Or x equals negative 5. Now, I know some are thinking, Miss Golly, that whole algebra tiles thing, I'm not real sure on that. I'm not real sure with working with those boxes and those tiles. Again, don't worry about the algebra tiles. I wanted to show you this process so you could actually see why it's called completing the square. Show you how we make a square by adding a certain number to both sides of the equation, and then how we end up in our equation with an expression squared, so we can then solve using square roots. So now let's actually go through this process without the algebra tiles. Let's go ahead and turn to page 294 in our student journal, and let's look at question number 7. So I want to go through this process without the algebra tiles. The first thing we need to do to make our perfect square is we want to divide our b value by 2. Now that b value should be super familiar to us from chapter 8 when we were graphing in standard form. We had to use b to find our vertex for many of our graphs. Remember, b is the x coefficient, or in other words, the number in front of x. So the b value in this case is negative 8. Negative 8 divided by 2 is negative 4. So we start off by dividing our b value by 2. Our next step then is to take the value from step 1 and square it. So take the value from step 1 and square it. Remember, whenever you square a number, the result is positive. If you need to enter that into your calculator, you have to make sure you're using parentheses. Negative 4 squared is positive 16. This is how we figure out how many tiles we had to put on each side to make our square. So if we were drawing this out, we would put 16 positive tiles on each side of our equation. So that's exactly what we have to do here. We have to add 16 onto both sides of our equation. So this is just like what we did with the algebra tiles. Instead of drawing out 16 little boxes, though, we're just going to add 16 to both sides. We won't be doing question 10, so you can go ahead and cross that out. After we added those tiles on, those boxes, our next step from there was to factor. Since we made a square, we know that the expressions in the parentheses have to be the same. The dimensions of the square have to be the same. So what you can do, if you want to, if it helps you, we can do our factoring where we multiply So we can factor, multiply to get, in this case it'd be 16, add to get -8, and we know we need to make a square. We know we need those numbers to be the same, so we're looking at -4 and -4. The numbers have to be the same. So x minus 4, that quantity squared, equals 1. One nice little shortcut here, if you don't want to always have to do the multiply add, notice that this number in the parentheses is the same number when we had b divided by 2. So that can make things a little bit quicker for you when factoring. This number in the parentheses is the same as our b divided by 2. It's the same as our step number 1. Now from here to solve, now we have just an x that's being squared. Now we can take the square root of both sides. We're left with x minus 4 equals, could be positive 1, or it could be -1. So x could equal 5, or x could equal 3. Those are our two solutions. Let's try that process again with number 9. Step number 1, we need to divide b by 2. The b value again is right in front of the x, the plain x to the first power. So in this case it's 7. Now you might be thinking, wait a minute, Miss Golly, 7 divided by 2, that doesn't work out very well. Don't worry, if you want to, it is absolutely fine. If you want to go ahead and turn that into a decimal, that's okay. Step 2, we take half of b and we square it. So the result of step 1 gets squared. And that equals 12 1/4. That 12 1/4 tells us how much we need to add onto both sides of our equation. We need to keep our equation balanced. Adding on the 12 1/4 completes our square. So we have to add that to both sides. Now again, to keep the factoring simple, we can jump right to those parentheses squared. 30 plus 12 1/4 is 42 1/4. We'll have an x in the parentheses, and then what joins it in there is our value from step 1. From here, now we can solve. We have an x that's just being squared. Now I can solve using square roots. On the left side, the square root undoes the squared. So I'm just left with x plus 3 1/2. Now the square root of 42 1/4 is positive 6 1/2, or negative 6 1/2. Subtract 3 1/2 from both sides. X equals positive 3 1/2, or x equals negative 10. Those would be our two solutions. Let's try one more of these. Let's look at number 13. Now, number 13 looks a little different than number 7 and number 9. Number 13, we have an x squared. We have our x to the first power, But now we have an extra number over on the left side. That looks different than numbers 7 and 9. So before we can start our process of dividing b by 2, we have to move this extra number over to the other side. So if we have a positive 9, we have to subtract 9 to move it to the other side. Before you can start your completing the square process of dividing b by 2, you need to make sure that your x squared term and your x to the first power term are alone on one side of the equation. So now that we have that, let's go ahead and go through our process one more time. Step 1, we need to divide our b value by 2. Our b value in this case is negative 12. So negative 12 divided by 2, we're going to get negative 6. Step number 2 then is to take that negative 6 and square it. Remember, anytime I square a number, the result is positive. No matter what your calculator tells you, the result is positive. Now that 36 tells us how many we need to add to each side so we get a perfect square. So we have to add 36 to both sides of the equation. We have to keep that equation balanced. Now, step 4, we have to factor. And remember, we're creating a perfect square. If you want to go through the work at this point, guys, if you want to go through the work and figure out what two numbers multiply to give you 36, and those same two numbers add to get negative 12, you can go through that whole factoring process if you'd like, or you can take the shortcut. And our shortcut is that the number in parentheses is just our b divided by 2. See, negative 9 plus 36, we end up with 27. Now my x is being squared. Now I can take the square root of both sides. So we have x minus 6 equals, and the square root of 27 doesn't work out all that great, so we're going to go ahead and round that off to 5.20 and negative 5.20. Add our 6 to both sides, so our x could be 11.20, and we really should be using those squiggly equal signs because we rounded the square root of 27. Anytime you round, you really should be using the squiggly equal sign. It means approximately. So our two solutions, x could be 11.2 or x could be approximately 0.8. This time I'd like you to go ahead and try out your progress check. You may use your notes on it if you'd like. If you have any questions, please ask.